What's up, you guys? Welcome back to the channel, and today I have what I consider a really fun beginner Python project. We're going to create a random board generator program for the board game Settlers of Catan. So when I first thought of this idea, I thought it was maybe a little too niche to do a tutorial on because I didn't know how many people would have this overlap of wanting to program in Python and randomly generate Catan boards. But if anyone else is like me, then your family always has you set up the board, and it gets really annoying and tedious to shuffle the tiles and the little number chits and everything. So I thought it would be a great beginner tutorial, and it's also just a great exercise in Python. It's a really beginner-friendly tutorial. We're going to do everything together, line by line, scratch. From scratch. You don't even really need to understand how Catan works if you want to just sort of go through this exercise of generating a random board. This can be a useful concept for any kind of game. I'm just going to kind of specifically tailor it towards Catan for the purpose of this video. But so I want to create a program that will let you endlessly generate more and more boards until you're done with the program. And it'll also let you decide whether you want to make a Catan board for the regular game of Catan, which is 2 to 4 players, or the expansion game of Catan, which is 5 to 6 players. And so you can keep generating new boards if you're not happy with it, and then once you're done and you like your board, you can just hit no and you'll be done. So let's dive into the actual code behind this project. Okay, so to randomly generate a Catan board, we're actually going to want to just make sure right up front we import this random module. This should have come installed with your Python install. It's one of the built-in modules, so just make sure to import it right in the beginning. And then the way I want this to work is I want it to sort of be able to be called over and over again. So basically I'm just going to say when the program boots up, we want to call this function new board. So this is basically it for code that needs to be sitting right here, because what we're going to do then is we're going to put all of this stuff that happens over and over again in a function by saying def and then space to indicate that we're defining a function. And then we need to define a function that we'll call new board. And so to get the answer of whether or not we want a regular or expansion board, we're going to get just an input from the user. So that's what you probably saw in the intro of the video, me typing in reg or exp. So to do that, we're just going to prompt the user with a question, which is going to be design a board for regular Catan, and we'll even say 2 to 4 players, and then or expansion, which is 5 to 6 players. Okay, and then we'll tell them type reg or exp. So you could, if this was an advanced tutorial and not a beginner friendly tutorial, you could make it where you have exception handling here, like what to do if your answer is not reg or exp. But we're going to assume the player is willing to cooperate with the program and type in reg or exp. Otherwise, it's just going to make the program exit. And so if you're not familiar with Catan, there's essentially 6 different types of tile you can have. And so we're just going to use a numerical system called 0, a desert, 1, a wheat, 2, a wood, 3, sheep, 4, the brick, and then 5, the ore, which is like rock. And then just to note, regular version has 19 tiles total, and then expansion has 30 tiles total. Okay, so total squares in the game. So now let's take a look at what to do if our reg or exp variable is equal to reg. And just an important thing, I don't want to assume we have, I want to assume we have absolute beginners maybe watching this video. If you want is equal to in your program, you need 2 equal signs, because just one, like what we're doing here, is the set a variable equal to some value operator. So this 2 equal signs is the check for equivalency. All right. So if it's a regular game, then we're going to have a list of all of our tiles. So we're going to have 1 desert, and then we're going to have 4 wheats, 4 woods, 4 sheeps. Let me make sure I got the right numbers here. Yeah, I only had 3 twos. So we need to create a list of all 19 of those tiles, right? So that's going to be 4 wheat, 4 wood, 4 sheep. And if you're not sure where I'm getting these numbers from, it's straight from the instruction book of how to play regular Catan. Okay, so then they're going to be 3 brick and 3 ore. That is the total, I believe. So let's count up, make sure I didn't do something silly here. So 3 times 4 is 12, plus 6 is 18, plus a desert is 19. Yep, okay. And so then the list of all the numbers you use in regular Catan is all the numbers 2 through 12. So basically all the combinations you can get with 2 dice. And there's 2 of everything except the 2 and the 12. And then there's no 7s because that actually moves the robber. So again, that's a little bit of Catan specific stuff, but whatever board game you're or whatever game you're generating a random version of, you need to have all of your options in lists here in the beginning, which is all of your values separated by commas inside these square brackets. Okay, and so initially our board is going to be a list of lists. So in regular Catan, you have 5 rows. In the expansion version, as we'll cover in the next section, this needs to get a little bit longer. But essentially, we're going to start populating this random board list with values of certain lengths. So again, if you're not familiar with Catan, the pieces are all these hexagons. I hope they're hexagons. They might be octagons. I can't remember off the top of my head. I think they're hexagons. But the row lengths are 3 tiles, 4 tiles, 5 tiles, 4 tiles, and 3 tiles. So essentially your board is 3 tiles wide, 4, 5, 4, 3. So this stuff, no matter what board you generate, these are the same for every single board, okay? So now we're going to go through and we're actually going to populate that board. So we'll say for I in range of 5. And so the way a Python loop works, a for loop, is if you just put one number in your range, it's going to go up to that number but not include that number. So for I in range 5 is going to run where I is equal to 0, 1, 2, 3, and 4, but it's not going to run I equals 5. It's not end inclusive, and it starts from 0, which works out really well because this index is 0, 1, 2, 3, 4. So we're populating the board list. We have 5 total rows, but 0 counts in programming. So we start from 0. And what we say is for I in range 5, while the length of board at our index value. Okay, so whatever list we're currently looking at. So when we're doing I of 0, while the length of our board is less than the row length at I, so is less than row lengths at I, then what do we want to do? We want to select a random tile. So we'll do tile equals random dot choice. And what's really cool about the choice operator in Python is that you actually just need to pass in a list, which I guess I didn't call. I did. Okay, it's just tiles. I thought I called it tiles list. But so all you have to do is random.choice and then a list of things, and it's going to select one thing out of that list. That's just how random.choice works. And so then what we'll do is we'll say board.I, so whatever row list we're currently doing, we want to append, which is add, that tile to that list. And then from our tiles list, we want to do tiles.remove and take that tile away. So this is obviously in terms of numbers right now and not in terms of words. And we'll take care of that later. But basically, this is how you're going to populate the boards list with a list of all of our numbers. And so what's really cool is if we set this up properly, then we're going to get a list of all of the rows just by doing this code. So what I'll do here is then I'll just print out the board. Okay, so this should be enough that we can run, and just as long as we type in reg here, we should get a random board. Okay, so what you'll see is it's not formatted that nice, and we don't have words yet, and we haven't assigned each tile a chit, like a number yet. But we've already got 413, 2513, 03. So this is a board. It is working properly already. There's just a lot of functionality we want to still add to it. So what we should do is we should say the board words are equal to, and then we should do a new function that we'll just call translate to text, okay? And so what we're going to pass in there is the board and how many rows, because we want to make this smart enough that it'll work for regular or expansion, okay? So what we'll do, and just to simplify what we're doing, is you saw the list we just had was all numbers. To make it really user-friendly and easy to give to someone to actually build the board, I think it'd be useful to do translate to text so that they can see sheep or brick, whatever, instead of 4, 3, 1 and have to look at like a cipher, you know, an indicator of what those words are. So what we'll do is we'll make a list and we'll say board text is equal to an empty list to start. Whoop. It's just going to be an empty list to start. And then what we'll do is for I in range rows, and here's where it's really useful to pass in how many rows we're doing, because once we get to the expansion board, this is not going to be a 5 anymore. So then we need to insert into board text dot append, right? We need to insert another empty list, so something that's just going to have nothing in it initially, because now what we do is we say for I in range and just again rows. Now we have what's called a nested for loop, so a second loop inside the first one. We say for j in range the length of our board list that we just passed in at I. So this is basically checking. I want to slow down here because again, I know some beginners will probably be looking at this. This is basically saying for however many rows I have total, I want to check and go through every single item in each row. So the length of my board list at row I is how many different times I need to take a number and convert it to text. So what we're going to do here is a series of ifs and elifs. And we're going to say if board list at ij is equal to 0, then what we want to do is take our board text list and we want to dot append the word desert, right? And so now what we're going to do is we're going to say elif our board list and just basically take this exact statement, and after the first one, instead of having them be ifs, we're going to have them be elifs. Whoop. There we go. And we're going to go through all the possible numbers, so 1 through 5 now, and we're going to say it goes desert, and then we had 1 as wheat, and then we take this same thing, Control C, and we're going to say if it's 2, then we want it to be wood. And what some people who aren't beginners and are maybe just watching more specifically for Catan might realize is rather than this super long if, elif, we could make a row of tile numerical values. So we could say like text list, and we could say desert, wheat, wood. Oh, I still have wheat down there for 3, but that's not correct. So it went desert, wheat, wood, sheep, and then brick, and then ore. Okay? And so because this is the order that there we go. Because this is the order that the tile numerical values go, then what you can do is you can just take board list ij, which will be one of these numerical values, and we can just do board text dot append whatever the text list index is at board list ij. Okay, so I'm gonna actually copy this line for just a second, and we're gonna come back to that. I just think it's important that we cover the most beginner-friendly version, and then we'll talk about a way to definitely optimize it. Okay, so let's finish this one, because I know that was probably a little bit of a confusing side tangent, but I think it is really important as a programmer to think through ways that your code can become more optimal, especially if you're doing a lot of repeating and like repeating blocks of code and only changing one little thing. There's probably a better way to do it, okay? So what we're doing with this code is we're saying for every row, for every column in each row, we check if that is a 0. If it is, then we add desert. If it's a 1, then we add wheat. If it's a 2, then we add wood. Okay? And so this is a lot of code, ifs and elif statements, just to basically do what at the end of each line, we're doing some board text dot append and then text based on what the value of board list is. So if we could make a list like this list that is all of the text values we're doing in this if-elif checker, and we could just replace all of this code with this line, then that's so much more optimal, right? We just got rid of like 20 lines of code, and once you get a little used to the idea of addressing a list inside of a list, which is effectively an array, this is also a pretty straightforward line of code. So we're basically saying the index from text list that we want to pull is whatever our numerical value is at that position in the board list. So I understand that this, to a very beginner, not familiar with object-oriented programming or Python, that can get a little hectic, a little messy, but trust me when I say this is a massive simplification of all the ifs and elifs you just saw. If it just doesn't make sense to you and you don't want to leave it that way, you can roll the video back to the ifs and elifs and you can leave it. It's going to work just as well. And what we're going to do is we're going to return the now list of board text, okay? So if we set this up correctly, what we'll see when we get to the expansion version of the board is we shouldn't have to modify this at all. It should already work exactly the same. Okay, so let's come back down. We now have this list of board words, and we're going to do something that's going to look kind of a lot like the tile assignment, except this time it's going to be a number assignment. So it'll be for I in range, and now the length of our board. Okay, so this is checking to see how many rows we have, and for j in range, the length of our board at I. Okay, so this should be very familiar to you now. It's just a nested for loop, which is saying for however many rows I have in my overall board list. And then the for j for loop is saying for however many columns are in each row, because they're not always standard, so we can't just hard code a value here. Then what we want to say is if the board's words at position ij, so that row and column, as long as it's not equal to desert, then we want to assign it a numerical value, okay? So this is a bit of Catan specific code because desert does not get a numerical value. So all the other pieces do. Deserts, you can't build on them. They don't give you a resource, so they don't get a numerical chit. So what we're gonna say then is our number is going to be equal to numbers list, numbers list, there we go. Sorry, it's going to be equal to a random dot choice, just like before, from our numbers list. Okay, so here's where I said it's very similar to tile assignment. And then what we're going to do is we're actually going to add to our board words. We're going to add to that list because it's more useful to us to have the text than it is to have the numerical values. So what we're going to do is we're going to add to board words a string. And to do a formatted string where we use a variable, you need an f, okay? So the f is just Python's way of saying this is a formatted string, which means I'm going to have a variable inside my string, inside these curly brackets. And so what I'm going to do is I'm going to basically say, okay, I'm going to use a dash. You could use a colon or just a space or nothing at all. But I'm going to use a dash and say to each tile in each row, I want to say wood, and then the number 7, and then we'll have a comma to separate the next value, and they'll say like brick, and then the number 9. And actually, now that I think about it, you'll never have wood with a 7 because you can't land on a 7, but that's silly. Okay, so numbers list dot remove, and then whatever our number just was, to make sure that, like, if we only have 2 3s, once we have 2 3s in there, there's going to be no more 3s in the list. So that's what the numbers list dot remove number does. And now the only thing left to do is to display the board in a much nicer way. So before we just kind of threw the whole list on the screen in one go, now what we're going to do is say for I in range 5, because remember we're in the regular board section, we're going to print the board words at I. So we're going to print out one row of text per row of our board. Okay, so this should be a complete regular version of the game board generator. So let's go ahead and do a regular board. And we got a error. So let's take a look at a little bit of debugging. So it tells us that our list index is out of range, which is a little suspect if we did this board words line correctly. So what I want to do is I want to boot this up, and I want to print out our board words list and make sure that it looks good, because I know the numerical list looked good. So let's do regular. And what you can see, okay, so this is actually really useful. This means that inside of our board text function, yep, we added each word individually, but we didn't add it inside the list for the rows. So we have a bunch of empty rows, okay? So this is a really easy fix, and it can be fixed just by board text at I dot append. This is saying add the text inside of these empty rows. So now if I run this again and I do a regular board, okay, it looks great. So it's now, you can see it's sticking the individual words for each tile inside of an overall list. And then down here you can see I'm going to get rid of that extra print board words because that helped us figure it out pretty quick. And so down here, you get this nice 5 rows. It goes 3, 4, 5, 4, 3, which is the same way you would build a Catan board. And it gives you each tile, and then it also gives you a numerical value for the tile. So that is great. And now a really simple add-on is just going to be, what do we change if it's equal to expansion instead, okay? So right, the first one was if it's regular. Now we just want to say if it's expansion. And the easy way to think about this is that it's basically it's basically 2 extra of each tile, but 1 extra desert. So 1 more 0, and then 2 more 1s, and then 2 more 2s, 2, 2, and then 2 more 3s, and then 2 more 4s, 4, 4, and then 5, 5, which should make sense because we have 5 actual commodity tiles. We have 1, 2, 3, 4, and 5, and then we get 1 extra desert. And if you remember from the beginning, the regular version has 19 tiles total and the expansion has 30. So this is going to be those 11 extra tiles. 10 of those are commodities, 2 of each type, and then 1 extra desert. And then for the numbers list, it's, I think, just 1 extra of each number. So 1 more 2, 1 more 3, 1 more 4, 1 more 5, 1 more 6, 1 more 8, no 7s still, 1 more 9, 1 more 10, 1 more 11, and then 1 more 12, even though no one likes the 12s. No offense if you really like 12s. Now, the board for the expansion is no longer 5 rows, it is 7, okay? So it is, instead of 3, 4, 5, 4, 3, it's 3, 4, 5, 6, 5, 4, 3. And then your programmer brain, your engineer brain, that should make sense to you because you've just added a 6 and a 5 row into this. There's 11 more tiles, right? So 7 total columns, 1 of each number, because the desert does not get a number, if you remember correctly. And so we have 10 total numbers here. We have essentially 1 through 12, which is 12 numbers, but no 1 and no 7, so 10 numbers. So 1 of each number, 2 of each commodity, 1 extra desert, 2 extra rows. Their lengths are 6 and 5 to sort of keep the, I guess, pyramid shape going up and down. But now we need to change this to for I in range 7 instead of 5. And then down at the bottom, this is also going to be for I in range 7 instead of 5. But what's really cool is other than this board words where we need to pass in a 7 now, these guys stay exactly the same because we're checking against things that were written generically so we can expand and change the board sizes. So I'm fairly confident that if we just set this up correctly, which is a big if, it should generate for us an expansion board just with those few changes. So let's look for an expansion board. Okay, and it looks great. Desert doesn't have any numbers. We have sheep, wood, or let's just do a quick spot check. I think we should have like 6 total sheep. You can actually see we've got these 3 sheep in a row. That would make people very unhappy, but that's the name of the game, baby. All right, so I think that looks really good. I think one critical, important, kind of fun piece of additional information we could give would be to let the user kind of run this several times without exiting the program and booting it back up. So we'll get another variable from an input that we'll call again, and we'll just say generate another board question mark, and then we'll give them the response that, hey, we need a yes or no here. And then we will say if again is equal to yes, then what we're actually going to do is call the function that we're actually inside right now. So if you think about this, the way we have written this code is translate to text is kind of on its own thing. We call that from in this new board function. But right now, really all the Python program is doing when you boot it up is importing the random module and then calling the new board function. And then as part of the new board function, when you've gotten your board, you have this option to generate another board. And so this sort of programming concept is sort of called recursion, where you can sort of go deeper and deeper into your own program, into this one function, deeper and deeper. But basically, until someone says no or pretty much anything other than the word yes, then they'll be able to exit the entire program. But as long as they're typing in yes, we'll let them do a new board. It will ask them again if they want a regular or expansion board. So let's boot this up and let's just test it a few times, make sure it works. So let's get a regular board. Great, it looks good. Do we want to generate another board? Yes. Let's do this one for an expansion. Okay, and that looks really good. Do we want another board? Yes. This time we'll do another regular. Okay, good enough. I like all these. I'm happy. Do we want another board? No. And now it exits our program. Okay, so I know I said this was a beginner-friendly tutorial, and then there were a few concepts that kind of burned your Python brain out a little bit, but at least in my household, Settlers of Catan is a game we play a ton. As a programmer and an engineer, I had fun building this program, and I do genuinely usually use this when we play a game of Catan, so I thought it'd be a fun tutorial. I thought it'd be something fun to go over with you guys. If you liked the video, be sure to leave a like on the video, subscribe to the channel. The code that you saw in this video will be available for download from a GitHub link in the description of this video. Let me know what you'd like to see more of on the channel in the future in the comments below. Be sure to let me know if you have any questions on what you saw here in the comments below as well. As always, good luck with your projects. Thanks for watching, and until next time, bye.